Hi, hello, welcome everyone to Upstream's LLMs in Automotive webinar today. We want to make sure that you understand that we understand there is not just one use case for artificial intelligence or LLMs in automotive. So whether you represent an OEM, a tier one supplier, a mobility provider, a dealership, or even an insurance provider, I encourage you to think about this discussion in the context that makes the most sense for your area of the industry. As was stated, I am Jennifer Tisdale, Automotive Industry Lead for Upstream North America. And before I introduce you to our panelists, I hope you'll allow me a moment to introduce you to our company. We are a cloud-based automotive data analytics platform and service provider. Today, we are currently monitoring over 25 million connected vehicles around the globe, and we are providing actionable data insights to our customers, the OEMs that we presently work with. If you've heard of Upstream before, you might think of us in the context of automotive cybersecurity, which, to be honest, is my first love. But we have recently expanded our reach into vehicle data health. And so we're going to talk about today how we work with our customers using artificial intelligence and data analytics to take their operations to make more meaningful engagements and to expand the way their data is working for them. So without further ado, let me introduce you to two of my most favorite people here at Upstream. Sarit, as was mentioned, is our VP of Product Management, and Elad leading our data science and engineering group. But perhaps the pair of you would like to take a few moments to give more context about your background.
Yes, sure. Thank you, Jennifer. Hi, everyone. I'm Sarit Kozokin, VP of Product Management here at Upstream, with nearly 2 decades of experience in product management and cybersecurity. I am dedicated to solving significant challenges for large enterprises, OEMs included, of course, and I've been leveraging AI to turn data into insights for their business growth. On a personal note, I would say that I'm also a passionate automotive enthusiast. And as such, I deeply appreciate how those solutions can shape the driver and the customer experience. And I'm very excited to be the center of making that transformation happen.
Amazing. Elad, how about you?
Yeah, so hi everyone. So I'm Elad, married to Yael, father to Adam and Essa. I am a data science engineering group manager in Upstream. I'm dealing with algorithms and engineering more than 12 years now, quite a few years out of it here in Upstream, where I'm mainly driven by data science and engineering challenges. I'm also VIN world and automotive world enthusiast, but also I'm an alternative music enthusiast and spend most of my free time in listening to new music. And it's nice being here.
Wait, you have free time, Elad? You have to give me your secret. I feel like I don't have enough free time. But before we jump into, some of the data challenges that we're seeing in the industry, Sarit, I think it's appropriate to recognize that we understand many of the auto OEMs today are making heavy investments into their own internal solutions for data management problems that they are confronted with. With so much activity and so much attention being put onto connected vehicle and SDVs, maybe you can talk a little bit about why this is a challenge and where the industry is at today based on your experience.
Yes, sure. The automakers industry is an extremely complex environment and ecosystem. We know that it's true for other industries, but I think here it's like even further. This means that they involve and generate massive amounts of data, and usually this data would come from different data sources. Different data sources can be from different systems, the vehicle ecosystem or the IT or the mobile application. And it's also kept and generated in a siloed way. So I think the siloed part is an important challenge. Like when you treat it in a siloed way, it's really hard to see the big picture. So that's the first challenge. Another challenge that automakers would deal with is usually that we're talking about extremely massive amount of data. So you need to scale, you need to make sure that you have the right infrastructure. This is really hard to handle. The last challenge, which I think is maybe the most important one, is the lack of contextualization, which means that you need to sync the data. You need to sync the raw data, put it in one platform, and try to make a coherent story out of it, providing insights on it. So when you bring the right data in the right way to the right place and add context on it, then this is where you get the most value from it. Otherwise, it's garbage in, garbage out, right? There's nothing you can really do, to make it better. And we do know OEMs, as you said, OEMs would try to do it on their own, but we often hear them say, we collect all that data, but we don't really know what to do with it. Or we collect our data, but we know that this is, only part of the data, and other departments would have their own data, and, they don't talk to each other. So even if you have the data, you have those challenges, and you try to show the data, the OEM would try to show this data. Usually it's not enough. It's not like a BI or analytic tools, that would show the data. It's the layer of talking to the data. We'll talk a lot about that as well. Talking to the data, or even talking with the data in order to extract the full value. Bi-directional, like you're exploring the data, but you also provide input. So all of that should be bi-directional. This is where you get the full value. All of those challenges, this is where AI would come into play, trying to solve those challenges, overcome those challenges. And I think that, we'll show you how AI can try to solve those major challenges, specifically in the OEM industry.
Well, I'm really excited about a couple of the items that you've identified here. Having worked in an OEM in the past, I am very familiar with how siloed things are within the machine of an automotive OEM. I agree that is a challenge. One, I'm not certain how we overcome as an individual company. It's industry-wide, but I think that people are starting to see the importance of bringing those missing puzzle pieces together. And number three, the context. I mean, for me, it's telling, the data is talking to us. It's telling us a story. And sometimes it feels like it's talking, but nobody's listening or only hearing pieces of the conversation, right? So the ability to tie it all together so it tells a comprehensive story is really exciting. And I feel getting a lot of much needed attention. But we're using a lot of buzzwords in our conversation already. We're talking about artificial intelligence, machine learning, large language models, Gen AI. Would the pair of you take a moment just to level set the audience today so that we're all speaking the same language on how we're defining these terms?
Yeah, so for some of you, these may be very common and usable everyday use words, but for you who aren't familiar, let's clear it out. AI would be the umbrella for everything else in this slide. It's basically any tech that mimics human intelligence to solve tasks. So then ML is just a subset of AI, where models learn patterns from data instead of handwritten rules, for example. Then LLMs are type of ML models, very advanced ones, but type of ML models trained on massive text to predict the next token. And this is great for reading, writing, code, chatting, if you use any one of the chatting apps. And last, GenAI is an AI that generates new content. This could be text, image, audio, code. And LLMs are just a GenAI for text. So we have image models if you use any of these apps, and GenAI for images. And LLMs are just for text, GenAI for text. I hope it clears some of the confusion for most of you.
I found it very helpful. So thank you so much for making sure we're all on the same page with how we're defining the terms. So we're talking a lot about the technology. And as I mentioned, I've worked in automotive tech for about 15 years in different capacities. But what you rarely hear in the industry is the opportunity or the tooling that blends both the technology with the business considerations. And so that's another area that has me very fascinated, especially in the context, Sarit, of product strategy. From your point of view, what is the effective way to integrate AI and ML into your product strategy?
Yeah, that's a very good question, Jennifer. You mentioned blending. I like that. So yeah, the optimal way is really blending the categories that Elad was so kindly and nicely talked to. So we run machine learning. This is mostly the algorithms that would generate the summaries, the predictions. I'm trying to bring it from my world. Predictions, evaluations of results, and the recommendations. But we want to make this accessible to customers. We want to make it accessible to customers in a visual way, putting it into the system, not as just a result, a one-time thing, but embed all the data points. We talked about the live digital twin. So embedding those data points into the representation in the system so it will be more comprehensive to them. And we also we want to make it something that replaces maybe some of the day-to-day activities that we can automate. Okay, that's another way of blending, the categories and using it in different ways. One of the things around product strategy that I think is important to mention is that users would like to trust the results. I think that's a big step that we need to take in order they need to gain trust in the results. Otherwise, they will not use the system. They use it as black box, right? Like generating those results. I don't know how you got to it. For them, it's like a black box. So it's important for those results to be explainable and visual, and for the user to really be able to explore the data and understand the why, how you got to those results. We know that they will engage more if it's shown in a comprehensive way, like the example I gave, putting it inside an existing, view existing assets and making it more interactive. So we talked about talking to the data, talking with the data. So it's visual, but also to make it more interactive so they can understand better, make ad hoc analysis and explore the data. So this is for the product strategy. This is really important to make a black box out of it, like machine learning as it is, but also make it more accessible to the users, make it more interactive. The main challenge when we talk about product strategy, that's another aspect, or the main challenge of customers looking at, okay, which strategy should I take, is should I buy or should I build? So they ask themselves, do I have the right skill sets, the right resources? Can I take this to the next level? Again, not just as an analytic tool, but really, embed the advanced use cases. I would say that there is some advantage in doing it in your own because you have access to the data, your users, your processes, but we talked about the challenges, especially around knowing your data, but that's not really enough. And I think other challenges would be around making sure that you have the right infrastructure and priority within the organization, like the buy-in from everyone else in order to really have a full solution. And to have support of this initiative continuously, like along the way. Usually it's like large initiatives for you to support those use cases. So if we're looking at the buy option, on the other hand, I think that the domain expertise and the consolidation of the data into one platform and the ability to reuse ready-made technology that usually vendors would offer, this is where you can get to the results and provide value to your users, to your end users, probably faster and with less resources. So you should take all those considerations into account when you come to decide, you know, if what is the way I'm going to do that? How do I implement it?
I absolutely love that conversation. And, you know, it's a wonderful conversation for the three of us to have, but I'm really looking forward to engaging our audience also, which is why we have a surprise poll to make sure you're paying attention and participating in this conversation. So on the subject of build, buy, or blend, please let us know when it comes to AI and automotive, which approach feels most realistic for you and your team. So while we're giving our friends who are listening to us a chance to respond to our poll, Elad, maybe you can start thinking about the process of taking vehicle data and converting it into true actionable insights for the OEMs and others in the industry. So while you're thinking about your response to that, let's see if we have polling results yet. Is it too soon? Do we have polling results? Hybrid. Yeah, okay. I'm pleasantly surprised by that. That was the one I was hoping for, to see a value proposition for a blended model, but I thought for sure we'd come in on the in-house build. So that's really great insight. Thank you for sharing. With that said, Elad, now's your moment. Talk to us about, you know, unifying vehicle data into action. Love to hear your thoughts on that.
So, Jennifer, are we going to have maybe the next slide will be helpful to,
There we go. Granted.
So definitely. So, first of all, yeah, during the same time I'm speaking, I'm very curious about how people respond here, but I'll be patient. First of all, speaking about pitfalls or what way to choose, it will be pretty obvious for the data scientists in the audience. And it's very important to understand, clean, and know your data. I mean, one holistic approach like throwing all your data on a model, doesn't matter which model, usually won't work here, also in other places and use cases, but it won't work. Second, we prefer to use, I mean, from our experience, we think it's better to use as many domain knowledge as possible to support any model or rule in the pipeline. This is the key rule to overcome the actionable insight challenges. Okay, this is just use the first key item. And third, the main idea, also I talk a lot about domain knowledge here. The main idea, I think, is through the whole process is digesting, enriching the data earliest as possible in the pipeline. So you build your feature store in a scalable way that serves for both the training and inference phases. That's in general. If I talk about pitfalls or which way to think, what way to achieve success here. And having this slide in front of us, what guides us is single timeline, real-time updates, and model-ready data processing, and how we do that in general. So in terms of data, and I'm going to left to right with the diagram, data sources, for those of you who I'm not sure that the audience here is very, it varies for many types of people and background. So I say it would be telematics, Okay, for those of you who know, DTCs, errors, warnings coming from the car, versions of hardware and firmware, metadata of the VINs, data warranty events from the dealers. These are some types or examples of the data sources. So these are should be continuously, in order to deliver value, to get actionable insights. These should be continuously ingested and normalized to a single scheme. Then, as we see it, it's better to enrich the VINs data early, as I said, by leveraging all data sources that were joined together at the beginning, as well as use case-oriented context or features, if I speak data science language. Some examples could be time alignment of all data sources for a single VIN, and vehicle history representations in terms of any other related data source. Now, part of this enrichment output, even before being trained or inferred further in the process, it's itself based on classic and ML and GenAI. Okay, this enrichment, sometimes it's based on domain knowledge or rules, but classic ML and GenAI are definitely tools to add this as well. So if I continue here, as we see it, what works for us is after enriching the data, it's later being used both as straightforward insights into the data platform, into the product platform, sorry, where the user can use this and investigate, but also to models inference. Okay, this step. At the same time, we can and we do persist all this data into a data lake where we keep digesting and enriching the data into further layers of abstraction and enrichment again that feeds our model training, but also the user investigation. Okay, every step, everything can be used either for insights, investigation, and model training. After all, model training are like users that gets lots of information and conclude with a model that can help better to look on the future. And last, the models are used to infer, as I say, future behaviors, attacks, predictions, as Sarit mentioned, and also explainability tools for root cause analysis. We may talk a bit more about it later. Yeah, so that's how we look at it. That's how we overcame the challenges from unified data set to actionable insights.
I think that is a lot of information to take in. So thank you for sharing that. And the visual really helps me in understanding the process around how the data is working with each other and with us. Are we moving to the next slide?
Yep.
Thank you. Thank you. So Elad, I believe this also falls into your wheelhouse, right? You're going to walk us through these models as well, VIN versus fleet.
Sure.
Awesome.
So we thought it will be helpful to show some examples or use cases, and we'll start with some cyber perspectives for ML models in automotive. Generally, we suggest to tackle the challenges that do require AI by separating single VINs from fleets or group of VINs. Now, single VIN model output, of course, can feed then fleet models or group of VIN models, but the core algorithms are separate because also the use cases are separate. The attacks in the case of cyber. And as a rule of thumb, in most use cases, we are trying to learn a normal VIN or group of VINs behavior, then alerting on anomalies that deviating from this normal behavior. There are many ways to do that. I'm sure you can imagine many of them. And the algorithm pipelines that we choose are the ones that evaluated as most accurate, scalable, and that fits our use cases the most. So for both cases, for example, we use traffic time series analysis. Okay, this is an example that can spot also, as an example, spikes or trend anomalies. We also use, if I continue with classic ML, we also use neural nets, trees ensembles, and advanced statistics, very depends on the use case, to detect anomalies in VIN or VINs using their real-time and historical context. This pipeline we discussed in the last slide, it also enables feeding, as I said, from another perspective, it also enables you feeding intermediate insights, okay, from VIN to some further models within the VIN world or the fleet. For instance, a VIN insight that are fed as features into fleet ML models that aims to detect a cyber attack can be based on VIN cyber insights. Or from the quality world, we can have a model that analyzes quality issues to produce.
Maybe we can pause right there just for a second, because I want to remind our listeners that there are many use cases for data, for connected vehicle data specifically within the industry. But I think our next slide brings up the use case that you were just teasing. And so the visual might be helpful to others if we could advance one slide and talk a little bit about, you mentioned cyber and you also mentioned quality. Let's start with quality. And let me add my 2 cents just real quick. One of the things I love when we have these conversations about whether it's after sales quality and data analytics, we get to talk with our customers about saving hard dollars through chatting with their data and data analytics and making that comprehensive data story a reality for them. Can you share a little bit, Elad, about the after sales quality use case and what you and your team have done in this capacity?
Yeah. So yeah, but by the way, it's not just me and my team. It requires much more. But my perspective on it is that, and I'm kidding, but this is the truth. So an example for the after sales quality detection, where we use both GenAI and classic ML. Would be some investigation tool, as can be seen in this chart. Maybe I'll start at one of the challenges in quality is how to first achieve root cause analysis on quality issues, right? And as we see all data sources, we can use all of these together to build an explainable model or models that can be used as leads for RCA. And the platform, if we continue, the platform can then also be used as an investigation platform to compare these affected issue vehicles versus healthy vehicles, and pull into investigation the VIN context with access to digital twin that was mentioned, and any sort of feature store. Then the engineer, as a user of such a use case, can feedback, and this goes on and on, continuously improving this process. And this is the chart, the chart at the top of the slide, but under this cute street light, we wanted to mention some other things. The third item, for example, proactive monitoring for spike detection and trend prediction. So in quality, you can also we use models to monitor any kind of event. This could be part replacement or quality events, and both to push anomalies, but also to predict what's expected. There are many kind of users and use cases in this area. Another one would be the pre-claim predictive or early detection as opposed to after sale. And a very good example for this one would be a battery life cycle, right? This is a very, very painful for many and a challenge for many OEMs.
Definitely a hot topic.
Yeah, sorry?
Say definitely a hot topic right now.
Yeah,
Sorry to interrupt.
It is. So using a model that can monitor before and after sale and replace the early checks will reduce lots of cost and build customer trust. So this is a classic place to use classic ML, but also GenAI. And last would be a predictive scale. So models can be used here to, models output can be used here for faster triage. And this can obviously lead to lower warranty cost, higher field reliability, and also clear narratives for QBRs and war rooms. Okay, these are all use cases, very practical. Yeah, there are much more, but this is, I think, enough to give some clue.
Yeah, and it makes me think about other use cases as well. And one of the headlines as of late in the industry was API security for automotive. We've been hearing a lot of chatter about that. It's been getting a lot of attention in social media. We've been doing blogs, et cetera, talking about the importance for API security. Can you step us through that use case and how AI is being leveraged in that capacity?
Of course, and this would be a good example of the hybrid build some, adopt some. So when we talk about API security, okay, so we, for example, we talk about API traffic transactions we would like to classify. Now, GenAI tools also they are able to bring key context to the table, which can reduce false positive. As ML tools sometimes are not enough alone. They can do the heavy lifting, but they're sometimes not enough. So ML tools can establish the baseline behavior for expected API traffic before GenAI models step in and dynamically refine detections, these alerts, based on any new updates pattern or app features, updated endpoints or app features. So these GenAI models, they filter, what I say that they filter noise. They're enabling the security operations centers team to focus on the real risks. And as I see it, it's basically an essential capability for building and maintaining efficiency and trust. Yeah, that would be a good example in API security.
I love it. It's so exciting. What an exciting time in the industry. I know there are challenges. Much of this has yet to be defined or to be formulaic. So it's exciting to be on the front end of these conversations. I want to go back because Sarit, you mentioned, I don't know, 5-ish slides ago about talking with our data. Like, can you tell us more about like, what does that mean? How do we do it? How do we listen to our data? How do we interact with it? I'd really love to learn more about that.
Yeah, and I think that part of what Elad was showing with the recurring, cycles with the feedback loop would really, tie into that. So we believe the next evolution is really conversational analytics, interacting with your data directly and having a bi-directional dialogue, impacting the data, enriching it, and of course, using GenAI for that. We have our own tool that we've been leveraging, an interactive tool where we've been leveraging GenAI in order to allow users to do that. OceanAI been used for some time, built into the platform, into our platform, for all the use cases. Okay, we talked about the examples of quality, like the issues, quality, early detection of issues, but also, of course, for security and more and more. Okay, that's like a kind of a built-in generic tool that can help you for all of this type of use cases and data. The example that we show here is really for a quality engineer in this case, trying to analyze DTC data for a specific month. Okay, looking at the correlated and aggregated data. That's what we do in our platform.
There we go. Looking for that new slide for you. Sorry, there you go.
And reviewing, not just like, that's like a raw data, like show me, aggregated based on the raw data. And then trying to split it like into specific DTCs. Elad talked about trends, right? We can show trends of DTCs, for example. But here it's more like show me the actual data. I may have seen it visually somewhere else. Now I want to explore it and see the actual information that this is based on and see, is this a real trend? And of course, from there, you can go and do this over and over again for various aspects of that data. One important note about this is where you see like a list, but you definitely can also ask to get this data in a visual way, meaning also like visualizing trends, visualizing the aggregated data in a way that will allow you to understand the story for the data to talk to you. I would like also again to mention the talk with the data and how this interactive tool, besides exploring data and besides analyzing, can be also used as something that is more of on the creation side of things, like more agentic. We have one really, really good example of creating detectors. We talked about detection, the detect part, that AI would really be helpful there. So if the user would like to create detectors through this interactive tool using GenAI, you can do this with OceanAI, doing it through guided steps, meaning you can articulate what you want to create, the logic of it, and then the tool would guide you. This is what we call the human in the loop, because you want to impact and make decisions along the way throughout the process. And this is where you will guide the tool to get to the actual content of that detector with the right logic that will help you detect. And of course, doing it, with no code and using text. And even at the end, it creates a kind of a draft where the user, that's the human in the loop, needs to do the final step in order to create that detector, in order for it to be accurate and really tailored to what the user needs. So I think this is a really good example of talking with your data.
That's amazing. Thank you. Thank you for explaining that. I think we're going to move into our second poll question.
Jennifer, would you? I just want to end, if it's possible,
please.
one more thing about it. Yeah. So, these are amazing. They are super cool, and the models behind it, and it doesn't ever stop evolving. But in order to make it possible, like to use them, it's not straightforward. And one essential step when trying to embed such a capability must include a methodology for unstructured to structured data. And if I may, I want to say 2 sentences about it.
Please.
And what's beautiful about it that you can use LLMs to help your LLMs work better. For example, one of the challenges is how to deal with high volume and unstructured claims text. That includes both, for example, customer and technician inputs. So if you use LLMs earlier in your pipeline, you can also extract meaningful keywords from these claims that can be used for any human or model to classify these claims. And then the nice thing, these can also be used for user who search for a talk with your data like tool to search claims by their attributes, by their keywords. And another example, a short one, would be a summarization of these claims. If you have an issue with so many claims, you don't know where to start, how to understand what's common for all these use cases together, you can just use this, and you can do it both with Tokyo data or within your product. Yeah, just wanted to add these two
So I
insights.
imagine, Elad, that shaves hours, if not days, off of somebody's job, compressing all of those insights from the data into a summation or a story or to find commonality. I think that's, I feel like I've used the word amazing a lot in this webinar, so forgive me for overusing the term, but I think it really is game changing for the industry at large when so many companies right now are being asked to do more with less. This helps them amplify the efficiency of their time and to help them achieve their goals much more quickly. At least that is my interpretation of that.
Sure.
I see you nodding your heads, both of you, so I hope that means I'm right. But with that, let's go into poll number 2. And this, I think, is an example that there's only so much time we have in this webinar, and we want to use and be respectful of everybody's time as well. So if there are use cases that we've talked about, or maybe you just want to have a conversation about what you're working on and how to leverage LLMs to help you meet your goals, something we did not discuss today in a way we've not chatted about it, let us know. If you want to have a demo or just a conversation, reach out to any of us via email or LinkedIn. Our contact information will be on the final slide. And once you vote, we'll go into some key takeaways, and then it will be time for Q&A. We've had several questions submitted to us by the audience, and Sarit and Elad will take your questions at that time if you're interested, as many as we can. So please go ahead and vote, and then we'll move in to key takeaways. I do believe we have a summation slide. If we can get to the next slide, and I can talk while people are voting. Thank you so much. So I was taking good notes throughout our discussions over the last week or two as we've been chatting about and preparing for this webinar. And I think the most obvious takeaway is that automotive is complex. We don't need to tell anybody that. We understand the complexity of the ecosystem from OEMs to T1s, as we talked about in the initial conversation, and the data is challenging. And with every increased line of connectivity that we're integrating into the industry, it creates other challenges and more data points that need to be digested, ingested, and interpreted. So for me, that was one of the largest takeaways, is to emphasize the complexity of the automotive ecosystem. Secondly, it is unfathomable to me the amount of opportunity that exists once artificial intelligence is introduced, and having these conversations about how to work with AI instead of for it, right? We want to make sure that we are in control of the AIs here and leveraging them to the benefit of the business and to the people using them. And that thirdly, LLMs are creating context around the story of your data. For me personally, that was an area that was new for me to learn and understand. And so I thank you both for sharing your insights in that capacity. I've heard the term LLMs throughout the last couple of years and increasingly over the last several months. And to be able to articulate it in such a way that it is creating it is actually tying the story together. It is the glue to the data that helps everything make more sense. So thank you for sharing that. And then I think finally, the discussion, it was the subject of our first polling question about build versus buy. I'd say that I most equate that to anyone who's ever attempted a DIY project in your home, a do-it-yourself project. Yes, it can be done. Sometimes it ends up costing you more money and more time trying to do it on your own versus bringing in an expert who can help you build your project faster and more seamlessly. But certainly loving the results of the initial poll, voting for the hybrid. And I think that makes a lot of sense. Sarit, you mentioned that the auto industry has a lot of data. It's their data. They understand what components of the data they are working with and why. So they have that owner insight that maybe a vendor wouldn't have, but being able to leverage expert vendors in this space that have already figured out the technologies behind making the data tell a story and how to communicate with it just seems to help them get to their goals faster. And so I'm loving the fact that this audience in particular, and hopefully that is indicative of the industry at large, is really open to that blended model of bringing both houses of expertise together to help get to their goal much faster, more efficiently, and hopefully more cost effectively. So thank you, both of you, for sharing those insights with us. And I'd love to take a look at the questions that we have from the audience and continue to let you shine, let your expertise shine to the audience. Are we getting questions? There we go. Thank you.
Yes, indeed we are, Jennifer. Thank you, everyone, for a great presentation. Before I launch into the Q&A, just a reminder, if you want to put forward a question, you can do so by typing it into the Q&A box. For anyone unfamiliar with Teams, that's the two overlapping speech bubbles you'll find at the top of your screen. A question that has come in asks, from your perspective, what is one misconception people may have when using LLMs in the automotive industry?
So maybe I'll take it, Jennifer. From our perspective or experience, the assumption that you can deploy or embed and use GenAI models, in this case LLMs, and live with the mistakes and the hallucinations is wrong. This is very clear to the data scientist in the audience, but without a strong validation methodology, you're just failing prod. So this is a misconception. Another one that I can think of is that LLM alone won't be sufficient. I can't emphasize enough that without deep domain knowledge, enrichment, the domain knowledge itself and its enrichment into the queried database, it won't be sufficient. That's misconceptions that I can think of.
Do you incorporate LLMs to explain digital signatories for non-technical users?
Yes, we do. So the digital signatures, by the way, for those of you who are not familiar with the output of root cause analysis models, where we help the user to get root cause analysis leads as a start. So we do these LLMs that we use to explain the digital signature use broader info and context as well to understand the signature and summarize it, and then to present it to any user per his or her flavor. Non-tech user, of course, can be one of them.
We have a member of the audience here who's a data scientist. They ask, can you please clarify exactly what you mean by enriching data?
Of course. So there are two perspectives of that. The one would be first adding some knowledge that isn't natively come with the raw data. Okay, we can use GenAI, LLMs are a good example of it. You can use LLMs to get a wider world context more than just having the raw data. So this way you can enrich. Second, maybe we have three perspectives. Second could be a domain expert just calculating some or gives a formula of how to take a raw signal from the data and better process it and digest it with some other signals to combine them to have a more comprehensible signal and then a feature for the model to train better, as well as for the user or the talk with your data model. So this, yeah, maybe it's 3, 2. This is what how I see it enrichment.
How do you deal with noise in the data, and how exactly do we determine if a fault is critical or noise?
So we gave an example in the API security case. This is a very good example of having noise and using LLMs in order to better decide. And this we could use. You can't use performance-wise. You can't use LLMs on every. There are billions of transactions a day. You can't use LLM on each of them, but you can reduce false positive and noise. And this way, if the person ask about the data pipeline, how we reduce noise at the beginning of the pipeline, we also use models and domain knowledge of which data is impossible, but we have to be careful not to lose the anomalies or the attacks or the vehicle issues when we clear these data. So we consider both when we do so.
It looks like those might be all the questions we've received. Is there anything that anyone would like to say before we wrap up?
I can say I enjoyed this session. It was very fun. It was lots of fun, and it's something we really like to talk about. So I'm happy I had the opportunity to talk about these things. That's from my side.
Yeah, I completely agree. This was fun. Thank you for the opportunity to share this. I hope our audience, would see this as beneficial information. And yeah, good luck to everyone working with AI.
Yes, thank you all for being here and joining the conversation with us today. Thank you, Elad and Sarit, for being so gracious with your time and expertise. I've learned a lot from you. I hope the audience has as well. And I hope we get to do it again. So thank you all so much.
And with that, we'll draw the webinar to a close. From Mobex, I'd like to thank Jennifer, Elad, and Sarit for sharing their insight with us, Upstream for making the event possible, and of course the audience for joining. There'll be an on-demand version of this webinar available for you to rewatch as soon as possible. But for now, thank you so much for listening, and goodbye.